Passwords are the one things that's required pretty much everywhere. But how do you know if a password is good or secure? And do good and secure mean the same thing? I was watching recently a video where somebody was showing how strong his password was using this website. So I decided to check it myself with a few very weak passwords. A warning here, never put your real passwords in any password checker. Let's try watermelon12. 2000 years to crack. Password 1234. Also 2000 years to crack. What do you think? Let's try two words together. Shipping November. 34,000 years to crack. And let's capitalize these two words. 2 billion years to crack. And you can even tweet your result. What do you think about these estimates? Hi, my name is Dan and these are security reflections for those with little or no computer knowledge but are curious about cybersecurity. Before you continue, please pause the video for a few moments to review and acknowledge this disclaimer. Now let's go down the rabbit hole. I am going to search for best password checkers and pick the first three results. This one, top 6, and this one. The top 6 gives us some best practices that we are going to review in another video. And here we have the ranked password checkers. I am familiar with Have I Been Pwned. It's an interesting tool, but we are going to discuss it some other time. Now I'm going to load the next three. This one, this one, and we already have the third one. Okay, let's try the same very weak passwords on each of these sites. I remind you again, never put your real passwords in any password checker. Watermelon12. 10,000 years to crack. Yet if you read below it says your password looks like it might just be a word and a few digits. This is a very common pattern and would be cracked very quickly. Password 1234. Same 10,000 years to crack. Shipping November. 138,000 years to crack. And capitalizing the two words, 9 billion years to crack. However, it does mention below that if these are dictionary words, it could be very easy to crack. In the interest of time, I'm just jumping to results for this site as they are identical with the last one. Next checker site, Watermelon12. Time to crack about 7 minutes. Password 1234. Time to crack 0 seconds. It's obvious that this site is using a different methodology. Shipping November. 117 seconds and capitalized. Almost 8 minutes to crack. It's interesting to observe that by deleting the last letter, the estimated time is increasing to 7 months. And the last site we test is a name that you might have heard of in the news. Here we go again. Watermelon12 does not give a numeric estimate, but instead, oops, your password could be cracked faster than you can say oops. That's quite suggestive. Password 1234, same oops, as well as for shipping November. The capitalized shipping November can be cracked faster than the time of a short walk. From all the sites we've seen so far, I find that the most useful for the following exercise is this one. And I remind you again, never put your real passwords in any password checker. Shipping November, And look what's happening if we remove the last letters. Time's up to 7 months. And then to 3 years, despite the fact that the password is a little bit shorter. Isn't that interesting? Let's now split the word November and insert a special character. The first and the last letters of the website name capitalized, and also the length of the website name, which is 15 character long, -1. 111 million years. Let's try again, just removing a letter from inside the words. 1000 years, and let's insert our particular string. 587 billion years. I wouldn't be surprised if you found it interesting and confusing at the same time. Is that intriguing? I do expect you to get better understanding of passwords with the following videos, and I believe things will become more clear as you follow along. Just don't give up. Let's look now for some inspiration to come up with a more interesting password for us to test. I will go with whatever pops up in my mind. Cat, avian, fish, fishing, netting, angling, trapping, pig, piggly wiggly, most time it's so difficult to come up with a new password and also remember all the passwords. And for this very reason we choose poor passwords most of the time. Okay, so let's try flying piglet in the fishnet. 3 years. Let's avoid the short words, better to use a longer word instead. Flying piglet skipping fishnet. And I can actually visualize this fantastic string. 394 years. Let's now separate the words with a special character, for example, the hyphen. This will increase the estimated cracking time to 81 million years. Because it's based on multiple words, we call this a passphrase. Let's see what is happening if we delete one letter. Time's up to 20 billion years. Deleting one more letter from the last word, the estimate goes up to 678 billion years. Unfortunately, it's not yet the time to get too happy about these results. Despite its impressive estimate, this specific password or passphrase may still be cracked very quickly, as we are going to see in the next video. And please ignore the congratulatory review you are being served. Fantastic, using this password makes you as secure as Fort Knox, because it's not. But for now, it's important to notice just how the estimate time is changing as we alter the words. And about the your passwords are never stored, even if they were, we have no idea who you are, I would say, yeah, right. We are going to see in future videos that actually they can find out quite a bit about who we are and what we do. Going forward, I'm asking you to ignore once the word trillion. Let's add back the end letters and insert our particular string in a place that is not between syllables. 2 billion years. I'm just ignoring the trillion in here. For why we would do that, let's just say that's because the cracking could be done with a supercomputer that is 1 trillion times faster. Let's try 2 more examples before we conclude this exercise. Delete the last word. 9,000 years. So it's shorter and much less than the one before. Let's now replace the last letter with the second letter of the website name. That is A. "9 billion years." And repeat with a less frequent letter like X. 106 trillion years, which is way more. These time values are debatable and must be taken with a lot of salt. The developers certainly have arguments supporting their methodology in specific contexts. That is not relevant for this exercise. What's actually important at this point is only to get some sense of how the cracking time varies with the complexity and the length of a password, or passphrase for that matter. In the next 2 videos, we are going to review a summary of how we built our test passphrase, and also a non-technical explanation of how passwords are cracked, including weaknesses of the passphrase we've just tested here. And again, and for the last time, I remind you to never put your real passwords in any password checker. Stay safe online.